All right, so Edwards, we want to simplify this square root, so if we break apart 24, what do we get?
2 2s, 3 2s, and 3.
Good, okay, great. And so, Amanda, what can come out of this root? All three or just two, right? A pair, because when you're doing square roots, you just take out pairs, right? So then what's left on the inside, we just multiply back together, okay? Eric, we don't like having square roots in the bottom, so what do we do? Good, multiply top and bottom by the square root of 3. Tavier, what's the top going to be if I do that?
6 square root.
Good, and how about the bottom?
3.
Good, and then these reduce, right? And so we end up with this as our final answer.
Is it the 2 plus or minus?
Oh, good question. So Edward's question was, when you take a square root, do you get a plus and a minus? So I'm glad that's in your mind. That's if you ever have a problem, like let's say we had this, x squared equals 24, and then to solve for x, you square root both sides, because the square cancels negatives, right, over here. So it's possible that it was positive or negative. But over here, if it starts positive, that's all it is. So good question. All right. So we're going to move forward with our lesson here today. We're on Unit 10, which is our first unit of trig. And we are on lesson 5. We're talking about right triangles today. Right triangles are kind of the foundation of trigonometry, that and angles. No, those I kind of looked at those examples and I think we're just going to go. It's not something that would probably ever come in handy for any of our purposes, so I'm just going to go. All right, let's go ahead and take a look at our objective today. So basically we're going to look at 3 different things. We're going to be finding missing sides using 3 different rules. One of the rules we're going to use is something called the 45-45-90 right triangle. You guys probably remember that from geometry. I mean, you may not remember how to do it, but it should sound familiar at least. You guys remember the other one? Nice job. That's right. The other special right triangle is a 30-60-90. And then finally, number 3, of course, we can't forget this guy. Pythagoras Theorem. I mean, this guy here, man, he gets all the credit. Although that theorem was around beforehand, used by other cultures in different ways, still he gets the credit. Pretty cool theorem. Pretty useful. So that's what we're looking at today. We're going to be finding missing sides of triangles today. So we've been talking about angles for the past 4 lessons, and now we're talking about triangles. And I told you at the beginning that trigonometry is the study of triangles and angles. So you're going to see how all this gets pulled together in the next few lessons after this one to kind of dive us into this new world of trigonometry. All right. So let's begin. Let's start off with the 45-45-90 right triangle. So what those numbers mean is those are the angles of that triangle. So for instance, we have a 90-degree angle, and then we have 2 45-degree angles there. Okay. Now, Little principle from geometry. Anytime you have a triangle with two angles that are the same, you also have two sides that are the same. So whatever this side is, this side's going to be exactly the same. Isosceles. So these are the same. Now the hypotenuse of these things. The hypotenuse is the longest side that's across from the right angle. The hypotenuse is because of the Pythagoras Theorem, which I'm not going to prove it right now in the interest of time, but you can actually use Pythagoras Theorem with these two s's to show that this side, the hypotenuse, comes out to be radical 2 times s. So s times radical 2. In other words, whatever those two legs are, the hypotenuse is radical 2 times larger. Okay? So how are we going to use this? Well, if you know the side, then all you have to do is just put a radical 2 next to it, which is multiplying. Multiply it by radical 2 and you can find your hypotenuse. Whereas, let's say though that you actually started here, right? But you wanted to find the side. Well, if you get from here to here by multiplying by radical 2, you would get from here to here by doing what? Dividing radical 2. And anytime you divide by a square root, there's the potential of needing to rationalize like we did at the beginning today, right? So that's the 45, 45, 90 right triangle there. So let's go ahead and take a look at a couple of examples. Have you guys got that diagram down good? All right. So let's do some examples here. We're going to have 3 examples for the 45, 45, and then I'll let you guys practice some. So example 1, part A, and all the way we're doing the same thing. We're finding the missing sides. All right. So we'll start with some easier ones, and we'll work our way up to some that require a little bit of math to actually get the answers. But some of these you could really just look at it and know the answers right away. Okay, so what's important here is that's kind of low-key, not obvious, is I had to put that 45 on there, because if I don't have that there, then you don't know if this is a 45, 45. If you don't know if this is a 45, 45, then you can't do anything about ready to do. So you kind of need to know if this is a 45, 45, 90. But here's what we learned. We learned that whatever one leg is, the other leg is the same. And therefore, B must be 5. Okay? We're also going to find this side up here. I didn't label it A. We also learned that the hypotenuse is, you can get the hypotenuse by taking the side and doing what with it? Now, when I'm solving these problems, I don't write all these little arrows and stuff. I'm just doing this for your notes, okay? I'm hoping that you guys can really just look at this and know that the answer is what? 5 times the square root of 2. That's it. It should be pretty snap straight to the answer. You got it. So, but it's nice to have the notes so when you look back later, it's not confusing where those numbers came from.
I'm not going to simplify that.
You can. So Justin asked about simplifying. So today in the warm-up, we looked at how to simplify a square root, right? You break down, you take out the pairs. Well, 2 is prime, so you're not going to be able to simplify that at all. So this is as good as it gets right there. All right, let's do another one. Part B. Okay. We can do that. I'm going to put a N here, an M here, a 6 here, and a 45 here. Okay, so 3 questions you can ask yourself to kind of guide you through these processes. First of all, is this a 45, 45, 90 right triangle? Okay, you got to make sure of that. Second, what side did they give you? Did they give you a leg or a hypotenuse? Hypotenuse. So I have the hypotenuse, so I want to find one of the legs, right? So the third question is, how do you get from the hypotenuse to the leg? What did we say you do? You divide by radical 2. So let me review those 3 questions with you. What kind of triangle is this? What side did they give me? And how do I get to the other side? Okay, those 3 questions will kind of get you through all of these problems today. So now how the heck do you divide 6 by radical 2? Well, you go like this, right? And we did that on our warm-up today. So we multiply the top and the bottom by radical 2, right? Which gives me 6 radical 2 over 2, which reduces to 3 radical 2. So this answer will be 3 radical 2. Now, if I know that this is 3 radical 2, what's this guy going to be? The same, right? All right, last one before I set you guys loose on some practice here. All right, so what kind of triangle are we looking at? 45, 45, 90. What side did they give me? A leg. How do you get from the leg to the other leg? It's the same, right? So that's going to be 3 radical 2 over 2. How do you get from a leg to a hypotenuse? You multiply by the square root of 2. Okay, so let's show our work over here on the side for that. I'm going to take 3 square root of 2 over 2, and I'm going to multiply that by the square root of 2. Right? Put that over 1. Multiply straight across. So what does this make when I multiply these together? 2 times 1 is 2, right? Those cross off. The answer is 3. So x equals 3. So that's the 45, 45, 90 right triangle, how you can find the missing sides of that kind of triangle. So I'm going to throw some student practices up at you. See how y'all do. All right. We'll start off easy and work our way up. That's my 90-degree angle. It doesn't look like one, but there's my 90-degree angle. Okay. Cleopatra, what did you get for y here? What's that? 9, good. Okay. Connor, what did you get for x?
9 squared 2.
Okay, so these two are the same, and this one is square root of 2 times bigger. It's the hypotenuse. Any questions about that? Right? Tammy, what did you get for x?
Square root of 2.
That is correct. Abel, what did you get for y?
2y, I got out of square root.
That's right. They're the same. So if you want to see the math there, to get from your hypotenuse to your leg, you do 2 divided by the square root of 2, which requires you to rationalize, which gives us the following. And those reduce. So you're just left with the square root of 2. All right. Let's take a look at the next one. Najib, what did you get for y?
7 square root of 2 over 2.
Good. And Cameron's not with us, so let's skedaddle on to Sydney. What did you get for x?
I got
7 square root of 2. So now if you want to know how we can get the hypotenuse, what you do is you take 7 radical 2 over 2, and you multiply it by, right, to get from the leg to the hypotenuse, you multiply it by the square root of 2. What does this make? 2, right? And the 2's cancel. So actually, we're not going to have a square root there. It's just going to be 7. Okay? All right. So that's the 45, 45, 90 right triangle rule. Right now we're going to move on to the 30, 60, 90. All right. 30, 60, 90 triangles look like this. They have one short leg, one long leg, and a hypotenuse. A lot of triangles have that. But unlike the 45, 45, 90, which is isosceles, this one has a long and a short leg, right? Well, here's how this works. The nice one to start with here is the short leg. So I'll call this S for, we'll say short. Okay. Well, it turns out on these guys that the hypotenuse is always twice as much. Okay, so whatever your short side is, if you multiply it by 2, not square root of 2, right? We're on a different triangle now. But if you multiply it by 2, you can get your hypotenuse. All right, which means, what if you started with a hypotenuse and you wanted to work your way backwards? You would just divide it by 2, right? Cut it in half. All right. The long leg is interesting. If you know your short leg, all you have to do is take your short leg and multiply it by the square root of 3. Okay, so multiply by the square root of 3. And therefore, if you were working backwards, you would divide by the square root of 3. So if you ever start with your long leg, then you would divide by the square root of 3. So they're a little bit more involved because they're not isosceles like the other one. But there it is. So it's really sweet when you start off with the short leg. All you have to do is put a radical 3 next to it and double it and you're done. If you get the hypotenuse, that's kind of nice too. Just cut it in half. You got the short leg and you can find the long leg pretty easily. Starting with the long leg can kind of be a pain in the butt sometimes. It depends on the circumstances. So we'll look at a few different examples to kind of illustrate those. So let's go ahead and start with example 2, part A. Now, first of all, we start with our question, what kind of triangle is this? Well, it's a 30, 60, 90. Now, some of you guys might be wondering, well, you only gave us one angle. How do I know the other one's a 30? Well, a triangle, the angles always have to add up to 180. So if one of them's 60, the other one's going to have to be 30. So they really only need to give you the 90-degree angle and one of the other ones. So question 1's accomplished. What kind of triangle we're looking at? 30, 60, 90. Question 2, what side did they give me? Long, short, or hypotenuse? Short. Short. So now when you got a short leg, how do you get to the, let's do the hypotenuse. What do? You multiply by 2. So what would that be?
18.
18. Right? Now, I also want to find my long leg over here, right? So, how do you find your long leg? You multiply by the square root of 3. So, what's this one going to be? 9 square root of 3. We're good. So, like I said, when you start with a short leg, pretty sweet. Double it, put a radical 3 next to it, done. Okay. Let's take a look at another one here. All right, part B. The next best situation is if they give you the hypotenuse. Unfortunately for ours, it's an odd number, so that's going to make fractions come into the picture. You'll see what I mean, but we got to know how to deal with that stuff, so we'll do it. All right, so what kind of triangle? 30, 60, 90. What side did they give me? That's a hypotenuse. So, now I didn't draw any arrows that show you how to get from a hypotenuse to the long leg, did I? I only showed you how to get from the hypotenuse to the short leg. So, we're going to go from the hypotenuse to the short leg. And what we said to do there was divide by 2. So that means that y, now you could, I guess you could write decimals, but I would encourage you not to. It wouldn't be wrong, but just that anything we're going to be doing with these, it's going to be in fraction form. So you might as well just get used to that. So what I'm going to say to do is just take 5 and divide it by 2 and leave it like that. Okay? So just put 5 over 2. Yeah, there won't be decimals on the test. That's what I'm telling you. Also, the stuff that we're going to use this for in our unit circle later, you're going to see there's no decimals. It's all fractions. So you want to know how to do this. Yeah.
When is the test?
It's probably not next week, but the week after.
So is this test going to include the coordinates?
Oh, yeah.
Should we do this earlier and not include the coordinates?
Shushel. Coordinates aren't that bad, actually.
They are.
Now, how do we get to the long leg? Square root of 3. So you're just going to take your fraction and multiply it by the square root of 3, which means just put it on top, basically. So we're good. So that's it. So those 3 questions are kind of helpful. What triangle? What side? How do I get to the others? All right. Last one that we'll do is we'll look at one of the ugliest ones. That's when they start you off with the long leg. Ugh, this one is ugly. But you guys are pre-cal students. You got this.
That's 15.
It is 15, yeah.
Wait, what?
2.
It looks like you said.
I'll fix it.
Yeah.
Okay, so 30, 60, 90 triangle. That's question number 1. Question number 2, what side? It's the long leg. Okay, so on the diagram that I drew for you guys for these, there's only one way to get away from your long leg. It's going to the short leg. And how do we get from the long leg to the short leg? Okay, so I'm going to show you the work on how to do that. But what we're doing is we're dividing by the square root of 3. So what you do is you take your little expression here, and you're going to divide it by the square root of 3. That just means put it in the bottom of the fraction. Now, usually what we would do is we would rationalize, right? Multiply the top and bottom by 3, and you could, and you'll still get the right answer if you complete your math all the way through. However, we have a square root on the top also, right? So guess what these can do since they're both square roots? You can reduce them just like you normally would. Okay? So, how many times does 3 go into 15? 5 times. So we don't have to rationalize. They kind of reduce the bottom out by itself. But just be aware that if it doesn't happen that way, you got to rationalize. Multiply the top and the bottom by the square root. All right, so in this case, this one comes out to be the square root of 5 over 2. And then after that, we can get to our hypotenuse by doing what? Multiplying by 2. Now, if I take the square root of 5 over 2 and I multiply it by 2, what happens to the 2's? And I'm left with square root of 5. Okay? So the only trick on these is, first of all, knowing your diagram and how to navigate yourself around the shape, but also doing the work with the square roots is a little bit confusing for some folks. So we'll see how you guys do with it. I'll throw one at you. See how you guys hold up. Start easy. And we'll work our way up to some more challenging stuff. It's 1, 2. And 3. Okay. There you go. Told you I'm an easy target now, you. All right, Ezekiel, what did you get for x here?
4 to the square root of 3.
I think that would be a good answer for y, because y is my long leg. So you take your short leg and multiply it by the square root of 3. Now on these, maybe it's hard to tell which one's the hypotenuse, but the hypotenuse is the one that's always across from your 90-degree angle. So if you ever have trouble identifying, that's how you can tell. Justin, what would a good answer be for our hypotenuse, though? That's right. All right, next one. Tanya, what did you get for our short leg here? 3, right? Because it's half of the hypotenuse. And then, Eman, what did you get for y? 2 radical 3? Close, it's 3 radical 3, because you take your short leg, right? And you multiply it by the square root of 3. So it's just going to be 3 root 3. Londra, how do we get from this leg to this leg? What do I do? That's right. So I'm going to show our work for that. That one's a little bit ugly. But you start like this, right? Then you multiply the top and the bottom by the square root of 3, which is going to give you 4 root 3 over 3. So that's what x would be, is 4 root 3 over 3. So, Jennifer, how do we get from this leg to the hypotenuse? You double it, right? So what is this times 2? 8 radical 3 over 3. When you double it, you only double the top, because you're thinking of it as 2 over 1, right? So top times top, bottom times bottom. So that one's a little bit awkward and weird, but there it is. All right, last one I want to throw at you guys for the day is Pythagoras Theorem. Now, Pythagoras Theorem works if you know 2 sides, and you can always find the third side. It doesn't have to be any kind of special triangle, though. It works on all right triangles. So, we'll call the legs A and B. We'll call the hypotenuse C. And you guys know Pythagoras Theorem by now, I'm sure. A squared plus B squared equals C squared. Okay. So, whole different ball game than the other ones. This one's different because all the other ones I only gave you one side and you can find the other 2. With Pythagoras Theorem, you need at least 2 sides, and your goal is to find the third side. But it's more powerful because it works on any triangle, Whereas the other two that I showed you, those are special right triangles. They only apply to certain types of triangles. Triangles with those angles in particular. So let's go ahead and start with an easier example. We'll move our way up to something maybe a little more challenging. Okay, so we have something squared plus something squared equals something squared. Now, it doesn't matter where they go except for one of them does matter. The hypotenuse has to go here. So what's my hypotenuse? X. So that has to go there. The 4 and the 5, it doesn't matter where they go in the other two spots. So 4 here, 5 here, and we're good. So what is 4 squared? What is 5 squared? This makes 41. And how do we solve for x? You square root both sides. Now usually when we have this, right, Edwards, we put a plus and a minus, but we're doing geometry right now. And with geometry, you can't have a negative side length. That doesn't make sense. So we'll leave out the negative possibility. But that's Pythagoras Theorem. So I just found that the third side has to be the square root of 41. So you need two sides. You can find the third. It works on any right triangle. Let's do another one. Okay, so we're going to have something squared plus something squared equals something squared. All right, which one's the hypotenuse? The regular 2, right? The other two are the leg that's radical 2, and the other leg is x. So what is 2 squared? 4. What is this squared? 2, right? The square cancels the root. So it's just 2. From here, we're just going to solve it using some basic algebra. What kind of a triangle is that?
40, 40.
Yeah, right? Because we just found out those two legs are the same. They're both root 2. So that's actually, in a disguised form, a 45, 45, 90 right triangle. We actually even did that one earlier today. If you look back in your notes, you'll see we did that one. All right. So that's Pythagoras Theorem. Let's throw it at you guys and see how you do with it. Well, there they are. Give you that one. That one's not going to be too bad. I want to throw one at you that might make you think for a second, though. There you go.